Hello everyone, and from today onwards I'm gonna start solving some coding problems. So my task is to solve at least 5 problems each day. So I would like to tell you that it will be great if you could do the same. So let's start. So our first question is square of a sorted array. So this is basically the problem, so let me read it. Sorted, so it is important that it is sorted. Okay, so it is sorted in increasing order, and we need to return the arrays of the squares of each number sorted in increasing order as well. So this is a sorted array that's given to us, and our task is to square all of these numbers, right, all of the elements of the array, and then store them in a vector or in an array and then sort them. Okay, so this is pretty much straightforward. So what we can do is, at first we will insert each and everything in an array. Okay, we will insert each and everything, square values of each and everything. So suppose -4, so its square will be 16, right? So then -1, its square will be 1. So we will insert them in a vector and then we will apply the sort to it. But that's gonna take O of n log n time, so we are gonna reduce the time complexity because we want to do it in so let's see the constants. So it can run in O of n log n time as well, so there's nothing wrong in that. And the follow-up is squaring each element, and so yeah, so they want us to find out in O of n time. So how we can do that in O of n time? So suppose this is our array, so -4 0 2 3. So suppose this is our array. Okay, so basically our answer will be sorted in this way. So 0, then 2 square is 4, 3 square is 9, then -4 square is 16. So this is our answer. This should be our answer. Okay, so what we can see is, so this, either this number will be the greatest or this number will be the greatest, right? Then either this or this, right? So it's not true that it won't happen that this will be greatest or this will be greatest, right? Because if our number is negative, so either this will be the greatest one or this will be the greatest one. So what we can do is, we can loop from the end. Okay, from this side we will loop from this side, and what we will see that we will check if the square of this number is greater or the square of this number is greater. Whichever is greater, we'll simply insert that in our array itself. So we will check if this is greater or this is greater. So obviously square of 4 is greater, so we will, at the end we will insert 16. Okay, then what we're gonna do is, we'll see, and similarly we will do every rest. Okay, then means we will increase this pointer to over here, then we are gonna check whether this is greater or this is greater. So similarly we will see that it's 9, so 9, we are gonna insert 9. Then we will decrease this pointer to over here. So let me show you the solution. Let me type the solution. So what I'm gonna do here is, I'm gonna take a vector. Okay, I'm gonna take a vector of integers. Okay, so let's call this the answer vector, and it's gonna be of size of nums dot size. Okay, so it will create us a vector of size nums. Okay, and then what I'm gonna do is, I'm gonna take some 2 pointers. So start, let's point to 0, and end, let's point to nums dot size -1. Okay, so let's take these 2 pointers. So start will point to 0 and end will point to the last index. So what I'm gonna do is, I'm gonna run a for loop from the end, right? So nums dot size, so we're gonna start from the end. So, and till where? Till 0th index I minus minus. Okay. Now I'm going to check if nums of start, the square of this, okay, if the square of this is greater than or equal to nums of end. Okay, if the start one is greater, then at ith index I'm gonna insert nums of start, right? So answer of I will be equals to what? Answer of I will be equals to the square of this, and since I have inserted the one at the start one, so I will have to increase the start pointer by 1. Okay, and if this is not the case, then else I'm gonna insert, let me just copy this, I'm gonna insert end, and I will also decrease the end pointer by 1. Right, so at the end I'm gonna return our answer. So I guess this should work pretty fine. So yeah, it's working. Let me submit it. Yeah, so it's working fine. So let us solve now next question. Okay, so the next question is rotate array. It's a medium level question. So given an array, rotate the array to the right by k steps where k is non-negative. Okay, so we will be given an array and an integer k. So our task is to rotate the array, or we can say we can shift the array to k digits. So the given array is, suppose this is the array 1 2 3 4 5 6. So this is the array and k is given as, so k is given as 3. So our task is to shift each and every element by 3 index. So this one will be at, I guess, here, 2 will be over here, then 3 will be over here. So our at the end our array should look like 4 5 6 1 2 3. So this is how our array should look like at the end. So how we can do this is, so we all know how to reverse an array, right? So to reverse an array, so suppose this is an array. So to reverse an array, what we can do is we are gonna take 2 pointers, start and end. Okay, then we will simply just swap these 2 values. So 5 and 1 will be swapped, then increase this pointer by 1 and decrease this pointer by 1. So now swap these 2. So 3, then 2. So in this way our array will be reversed. So similar thing we are gonna do over here. So this was our array. So after reversing, what we will have, so we will have 6 5 4 3 2 1. So this is what we will be having after reversing this given array. Okay, so now what we can see is our k was 3, right? Our k was 3. So what we can do is we can simply reverse these 3 elements, right? So this 3, after reversing this 3, we will get 5 4 5 6. Okay, and our these 2 will be as, this 3 will be as it is. So now see, we have done till this part is we have fix this part. Okay, so this part is sorted. So now our task is to reverse this, or you can say this. So next what we will do is we will reverse the last n minus k elements, that is 1, 2, 3. We will reverse this, and here 4, 5, 6. So this is what our answer is, or what we have wanted in our answer. So let's solve that quickly. Okay, so what I'm gonna do is I'm gonna make a void function, a reverse. Okay, it's gonna take a vector of integer by reference. Now array, let's name this array. Okay, and it's gonna take a pointer start and a pointer end. So what we are gonna do is, while start is less than end, okay, while start is less than end, what we are gonna do is we'll simply swap all of the values. So to swap all of the values, what we are gonna do is start. So we're gonna store the first element of the start, and now the array of start will be equals to array of end, then array of end will be equals to, and array of end will be equals to temporary variable that we are using. And what we are going to do is start plus plus end minus minus. So this is a function that is used to reverse our array, right? So now what we are going to do, so let's take int n is nums dot size. So what we are going to do is, at first, so there is a thing that k can be up to n, right? So it can be more than n as well. So what we are going to do is we'll change k by k modulus of n. Okay, by doing this, if suppose k is greater than n, right? So here, suppose if it was k was suppose 9, it was 9, and there are total 1, 2, 3, 4, 5, 6 elements, right? So 9 by 6, so our k will be changed to 9 modulus 6, so that is equals to 3. Okay, so that's why we have changed k with this one. Now our task is to reverse or call this function, so where we will send nums. And so at first what we're going to do is we will be changing the whole array, or we will be reversing the whole array, right? So the first step was to reverse whole array. This was the first step, right? This was the first step. This is our first step, to reverse whole array. Then our next step is to reverse the first k elements. These are the first k elements. So our next step is to reverse the first k elements. So let me just copy this and paste. So next step is to reverse the first k elements. So k is our how much? So whatever k is, here the k value was here the k value was 3, right? So since it's 0 based indexing, so 0, 1, 2, so we'll be sending the last one was, that's why we sent it k minus 1. So next is from k to n minus 1. Okay, so let me run it. So it's working fine. Let me submit it. So it's working fine. So let's shift to next question. So next question is next greater element 3. Also a medium level question. When a positive integer n, find the smallest integer which has exactly the same digits existing in the integer n and is greater in value than n. If no such integer exists, return -1. So basically, to understand this question, what I'm gonna do is it's gonna return an integer. So let's just simply return n. Okay, to understand the question, so let me just change this value to some random, okay, some random value. So let me run it. So the answer should be, expected answer should be this 3. Okay, so now it's gonna be clear, I guess. So let's see. So what the question says is, we will be given an integer n, find the smallest integer which has exactly the same digits existing in the integer n and is greater in value than n. Okay. So this was our input. So our expected output is 1 2 3 7 2 3 5. Okay, so our answer, how our answer is changing. So we want exactly the same digits that are in our given input, okay, and the number that we will be changing should be just greater than the actual number, or you can say n is greater in value than n. Okay, the given answer should be greater than in value of the n, and it should be the smallest one. Find the smallest integer which has exactly the same existing digits and is greater in value. Okay, so what we will do is, so let's take this 1 2 3 5 7. So this is our given number, and this is what our answer will like. Okay, this is our answer. So here what we can see is, if our answer is already in decreasing order, see, if our answer is decreasing order, that is suppose 3 1 0, so there is no way in which we can change this number, right? Because there is no other way by which we can create a number that has exactly the same digits as this number and is greater, because the number is in decreasing order. So don't consider this as an integer, let's consider this as an string. Okay, so then only we will be able to see whether the number is decreasing or increasing. So if the number is decreasing, there is no way that we can change that number to something greater than that number. So our first step is to change this integer to string. So let us do that first. So we have changed it. Right. So our first step is to convert this into a string, and our next step is to check whether this string is in decreasing order. Okay, so in this way, if the string is in this way, then we will simply return -1 because we can't do anything else. Okay, so if it's not in decreasing order, then that means that there is a particular number that can be interchanged. Okay, so what we will do is we will start from the end. Okay, we will loop from the end and check. We will check. So suppose we will start from over here. Okay, let me check this. So we will start from over here. We'll start from over here and check whether this number is less than this number. Okay, means something that's after the number. If not, we'll just move ahead. and the point where we will reach where a number is less than its next number, then we will stop. So suppose in this index we saw that it's less than 7, means now we can change these two numbers, right? We can change these two numbers, because earlier what the situation was, so suppose only this, so just assume only this, so it was in decreasing order, right? So this number was in decreasing order, that's why we were unable to change any of the integers. So now we are over in 5 and we saw that it's less than 7. Okay, so it's less than 7. So what does that mean? It means that we can somehow change and this number with anything that's greater than 5. Okay, that is present in between this. Okay, so we saw that 5 is a number that is lesser than its next number, that is 7. So what we will do is we will store this index. So let's say it's I. Okay, now what we will do is we will again iterate from the last index, till I plus 1 index. Okay, till here we will check till here. So what we will do is we'll see which is the element that's just greater than 5. Okay, so here we saw that 7 is just greater than 5. So what we will do is we'll just store this in an index j. So what we will do is we will interchange the values j and I. So now the interchange value, after interchanging, the value will look like something like this: 7, 5, 3, 2. Okay, so this is what our interchange value will look like. But as you can see that it is one of our answer, okay, which is greater than it has exactly the same digits as our given input, and it is also greater than our given input. But this is not our answer, because this is not the smallest number that is greater than our given answer, because the smallest will be 1, 2, 3, 7, 2, 3, 5, right? Because this is the smallest. So what we did was we just interchanged these two numbers, right? So our next task is to reverse this portion. Okay, we'll be reversing this portion. So since earlier it was in non-decreasing order, means it wasn't means everything was in non-decreasing order. Sorry, in decreasing order. It was in decreasing order. So now our task is to somehow change it in increasing order. That's why what we will do is we will interchange this, means we will reverse everything, and now it's in increasing order, means 2 is the lowest number, then it will be highest. So I know it will be a pretty means confusing to understand in this way, but I will be showing you the code, and then I hope that it will be easier for you to understand. So let's start solving the question. So our first step was to change the given integer into a string. So let's do that. So string s. Okay, so I'm going to use a stl, so that is toString. So it will change our integer n into a string s. Okay, so our next step is to iterate over a string and check whether it's in decreasing order or not. Okay, so to check that, what we will do is we will take a Boolean flag and initialize it with a true value. So let's iterate. Okay, so what I did was it will be till n minus 1, else it will give us an error. So what I did is s of I minus 0, so after doing this it will be converted, the character will be converted into a number. Okay, so if we will check if this means if this is means smaller than this number, then we will say that it's in decreasing order. It's in increasing order. So now we'll check if flag is true, means if flag is still 1, then we will simply return -1. Okay, so our first step is done, we have checked. Then our next step is to find the I where this I, right? So where it's not decreasing. So what we will be doing is we will be running a for loop from end. So I will start from n minus 2, I greater than equals to 0, then I minus minus. So what I will do is I will check if s of I minus 0, if this is less than s of I plus 1 minus 0. If that's the case, then we will break from here. Okay, so now we will get the ith index where means the number is decreasing. Okay, so next is to find the jth index, so that is to find which number is just greater than 5. Okay, in this case which number is just greater than 5. So here it was 7. So let's do this. So let's again run a for loop from where? From j equals to n minus 1, from the last index to up to j is greater than I, then j minus minus. So here what I'm going to do is I'm going to check if s of j minus 0, if this is greater than s of I minus 0, if this is greater, then we will be breaking up from here. So in this, now what we'll be getting the ith and jth index as well. Okay, so now our task is to interchange, right? So our task is now to interchange these two numbers. So let's do that quickly. So char temp will store what? So char temp will store s of I, then s of I will be equals to s of j, then s of j will be equals to temp. Okay, so now we'll write a reverse function. It will take s, then it's gonna change from this to n minus 1. Okay, so suppose we wrote the reverse function, and at the end what we're gonna do is we'll be returning. So let's store, since it has to be in 32 bits, so yeah, so let's use long here. So long output will be storing std stol. So what it does is it changes the string into a long. Okay, if we wrote something like this stoi, it changes string to integer, and stol changes string to long. Okay, so at the end we are going to return output. Okay, and we will check if the output is greater than int max. Okay, if the output is greater than int max, then we will be returning -1. Okay, else we will be returning output. Okay, so since our our answer can have greater values than int max, that's why we store it in long, and we check whether output is greater than int max. If it's greater than int max, then we will return -1, else we will return output. So let me just quickly write the reverse function. So void reverse is gonna take a string s, then it's gonna take a start end. Okay, so while start is less than end, what we're gonna do is char temp will store s of start, then s of start will be equals to s of end, s of n will be equals to temp, then start plus plus and minus minus. So let me just remove this extra space and let me run it. So we got a compiler error because we just took the same name. So let me just change this to A. So let me run again. So it's working fine. Let me submit it. So it says a wrong answer. Output was this, expected was this. So where it's getting wrong? So I guess this is not reversing. It's not reversing. There is a problem in reverse or what? Okay, so I will have to send it by reference. So let me just test this case. Okay, it's working fine now. Okay, so it's working fine. So let's solve the next question. So next question is majority element given an array nums of integer n, return the majority element. Appears the majority element is an element that appears more than n by 2 times. Okay, so we'll be given an integer having duplicate elements. So our task is to find the majority elements that's present in our array. So one basic solution is to sort the array. Okay, we will sort the array and then we will check the majority element. That is one way. And next way is using you can say, like, we can also use a map to store all of the elements and keep a counter of each and every element and check whether that's a majority element, and measure it by checking if that number is present more than n by 2 times. Okay, or we can use a very important algorithm that is used to find the majority element, and that is Moore's voting algorithm. Okay, so in this algorithm what we will do is we'll assume that, let me show you. So let's take an example. So say 3 4 1 1 2 1 1 1. Here total elements are 1 2 3 4 5 6 7 8. So there are total 8 elements, and n by 2, that is 8 by 2, is 4. So an element or a number that is present more than 4 times is a majority element. So here we can see that 1 is present more than 4 times. That means, so our answer will be 1. 1 will be our answer. So what does this Moore's voting algorithm do is, we will assume at first that this is our majority element. So we will assume that our majority element is present at 0th index. And what we will do is, we will run a for loop. Okay, and we will take a counter as well. Okay, we'll store a counter. Okay, that's value will be initialize to 0 at first. So what we will say that 3, at first we will be assuming that 3 is our majority element. Then we will iterate over the array and check. Okay, so we will see if our means ith element is equals to, so here major. Okay, so this our majority is equals to, at present it's at 0th index, that is 3 value 3. Okay, so we'll check if this value is same. If it's same, then we will change the counter to 1, then we will move ahead. So now we are over here. Okay, we will see that whether it's equals to majority is equals majority means now the ith, whether the ith index is same as that of majority. So it's not, right? It's 4 and here the majority element is 3. So what we will do is we will reduce the count. So count will be changed to again 0, and if at any point count reaches 0, we'll also change this to that new element, right? So now it's 4. Now we went over here, we saw that it's not so it's not the majority element, right? So what we will do is, and also when we change this to 4, what we will do is we will change this 0 to 1 as well. Now we saw that it's 1, so we'll just make it 0 and then again 1. Okay, and then we will change this to 1. Now we reached over here and we saw that it's same as that of majority, so count will be increased to 2. Count will be increased to 2. So now the new element is 2. So we are over here. The new element is 2, that is not equal to majority, so reduce count. So count is 1 now. Then we will be over here. Then we saw that it's equals to majority, so increase count. Count will be increased by 2. Then we reach over here, increase count by 1, so count will be 3. And over here count will be 4. So now it says that major element is 1, right? So it just gives us the majority element, and it doesn't prove that the majority element is present more than n by 2 times. So to find whether our majority element is present more than n by 2 times, what we will do is we will again initialize count to 0, and again iterate over the array and check with this. Check if the ith element is equals to majority. If yes, then we will increase count, right? So after traveling, the count will increase. The count will be 1, 2, 3, 4, 5. So the count will be equals to 5. Okay, after traveling the whole array, the count will be equals to 5. Then if the count is greater than n by 2 times, then we're gonna say that yes, this is our majority element. So this is Moody's voting algorithm. So let me just solve it now. So our task is to return the number. Okay, so at first we will be initialize. So major is equals to nums of 0th index. Okay, and let's take count as 0. Okay, so rather than storing this value, what I'll do is I will just store the index. Okay, so let's now run a for loop equals to 0. Listen. Okay, so what I will do is, if our nums of I is equals to nums of major, okay, if that's equals to nums of major, so I will be increasing count. Else if that's not equal, what we will do, I will do is I will reduce count. Okay, I will reduce count. And if at any point count is equals to 0, if the count becomes 0, then my task is to, then I will change the count to 1 and major will be equals to ith index. Okay, by this, after doing this, I will get an majority index. Okay, So now I will change the count to 0, then again run a for loop. So again run a for loop, and I will check if nums of I is equals to nums of major. If that's the case, then I'll increase count. Okay, at the end, if count is greater than nums dot size, if it's greater than this, then I'll be returning nums of major. Okay, if that's not the case, then what I was supposed to return, you may assume. Okay, so assume, so it's working. Let me submit it. So yeah, so it's so it's saying that it's just faster than 6.4%, which is pretty low. Let me just remove this. So yeah, now the time means increase. So yeah, so this question is done. Let me move to the next question. So the next question is given here all the elements that appear more than n by 3 times. Okay, so here it's also the Moody's voting. Here also I will be using Moody's voting algorithm, but here it is given that so we need to find all the elements that appear more than n by 3 times, and the answer will be storing in a vector. Okay, so let me just take one example. N by 3 times. So let me just take this example. So 2, 5, 1, 1, 1, 2, 2. Okay. So n is equals to 7. Here n is equals to 7. So n by 3 means 7 by 3 is around 2. Okay. So every number that is present more than 2 times is a majority element. So here it's 2 and 1. So our answer will be 1 and 2. Okay. Now one thing is that can more than 2 numbers be majority element? So is it possible that a number like more than 2 numbers are in our answer? That's not possible, because for if so it's just see like that. Okay, total numbers are n. Okay, total number is n. Let me just okay, so total number is n, and one number is greater than n by 3, right? N by 3. So there are say 2 numbers. Okay, n by 3, n by 3. Okay, so what will the answer of this? Can we and also it's greater than n by 3, right? So a number is greater than n by 3. So it's not possible for another number to be also greater than n by 3. So at max we'll be having 2 numbers that that will be majority elements. So more than 2 we cannot have. So our answer will always have 2 values to it. So it's not always true that it can also have 1, but at max it will have 2 values. Okay, so here also we'll be finding this means it's just the same as Moore's voting algorithm, but here instead of one we'll be finding two elements. Okay, so instead of means one majority element, we'll be finding two. So what I will do is, here let's take n is nums dot size. Okay, nums dot size. Then let's create our vector of answer, where we'll be storing answer. Okay, next int maj1 means major 1, that's initialized to -1. Then major 2, that's initialized to -1 as well. And count 1 is 0, count 2 is 0. Okay, so count 1 gives a track of the first element. So now what I will do is, I will be iterating. So for to I in nums, what I will do is, if I is equals to okay, so here I'm just storing, it's not the index, okay, it's just the value. So let me just initialize that it's -1. So yeah, so the numbers can be anything. So we can just simply take this nums1. If it's equals to num1, then what I will do is, I will increase count1. Okay, else if I is equals to not num1, it's major 2. If it's equals to major 2, I will increase count 2. Then okay, so else if, now we will not else if, so we will check if count 1 is equals to, if it's equals to 0, if count 1 is equals to 0. So if count 1 is equals to 0, if count 1 becomes 0, then what I will do is, I will just simply change major 1 will be changed to I, then count 1 will be equals to 1. If count 2 is equals to 0, what I will do is, I will change major 2 to I, okay, and count 2 will be equals to 1. Okay, so else nothing works, then what I will do is, let me just write it over here. Else if it's not equals to anything, then just simply count 1 minus minus, count 2 minus minus. Okay, so from here we will get two majority elements. Okay, then I will change this to count, I will change count 1 and 2 to 0. Okay, then again for auto I and nums, what I will do is, if I is equals to nums, if I is equals to major 1 cnt1 plus plus, then another is if I is equals to major 2 cnt2 plus plus. Okay, now we will get the count of each and every element. Now we will check if cnt1 is greater than n by 3. If it's n greater than n by 3, so answer dot pushback major 1. Then another is, let me just copy this, if count 2 is greater than n by 3, then I will put 2. Okay, and at the end I'll be returning answer. Expected was 3, So where it's getting wrong. Let me just write it at the end, else if yeah, it's working fine now. Let me just submit it. It says wrong answer, expected was -1. Okay, so we got a wrong answer. So let's check this. So yeah. So what we were doing is we're inserting it. See if I is equals to major 1, we were increasing count, and again we will checking the same condition. So here instead of if we will have else if. Now either this will run, this will work, or this will work. Both will not work. So let me just try this. Let me just copy this. I think this should work now. Yeah, it's working fine. Let's submit it. Yeah, so it's working fine. So we have done 5 problems today. So I forgot to write. So here we will write the approach how we will we solve each and every question. So for square of rotated array, we will write the approach. Everything will be written in the next session. I forgot to write it today, but I will write it in the next session. So that's all for today. Thank you and have a nice day.